Alright, in this video we're going to cover the DMA 20 test review. I plan on covering all 14 problems in this video, but I may split it up. It just depends on how much time it takes. So feel free to scroll to the end. I don't know how far we'll get. If I don't cover all 14, I'll make a second video and we'll go from there. But for this first problem, we want to perform the operation. Make sure you show your work and simplify all fractions. So 8 1/3 plus 3 2/5. Remember to add fractions, or to add mixed numbers, but in this case we're adding fractions as well. We need a common denominator, and that common denominator would be 15. Notice that 3 times 5 will give you 15, so 1 times 5 will give you 5. And I'm just going to bring the 8 over here as well. So we have 8 5/15. That's the same thing as 8 1/3. And this one here, 5 times 3 gives you 15, and 2 times 3 will give you 6. Let's bring that 3 over. And adding these two mixed numbers together, we get 5 plus 6, that's going to be 11 over 15, and 8 plus 3 is 11. So we have 11 11/15. This fraction 11/15 is simplified. It's not improper, so we don't have to do anything else with this. That's fine. Be careful though if you did have a improper fraction here. We talked about that in class, about converting this back to a mixed number and then maybe adding something on to 11. But in this case, you're good. Nothing to do there. Question B, 9 3/5 minus 4 13/15. Lucky us, we have to get a common denominator, and it's the same thing that we got back here for this one, even though our two original denominators are different. So 15 is going to be the common denominator. Here, 5 times 3 gives you 15, so 3 times 3 gives you 9. And let's bring that 9 on over. And this one here, since we did not change our denominator, we do not change the numerator, and we just bring that 4 over, and we need to subtract. However, you must be careful here. Recall I mentioned this in class, and there are several videos I have on subtracting mixed numbers, or several examples at least, that I did ask you to watch too outside of class. So here in this problem we have to borrow. Some of you may prefer to convert these to improper fractions and deal with them. I prefer to borrow. That's just the way I prefer to do it. So the reason why we have to borrow is because we cannot take 9 subtract 13. So what we do here, we want to borrow 1 from 9. So I'm going to rewrite that 9 as 8 15/15. That is the exact same thing as 9. 9 is the same thing as 8 15/15. 8 and 1 still gives you 9. But I'm going to come back over here and write that 9/15 beside it, and we're going to add that to the 15/15. That's the idea of borrowing. And when we do that, we actually end up with 8 24/15. I got the 24/15 by taking 15 plus 9. And now let's bring this fraction on across. So therefore we have 4 13/15. Now we can subtract. We can take 24 minus 13. 24 minus 13, that gives you 11. We'll leave our 15 alone, and 8 minus 4 gives you 4. So we have 4 11/15. Kind of ironic we got the 11/15 again. Now, this right here, I mentioned this in class as well, and also on the other videos, but a way to take a shortcut through this borrowing step, when we borrow, notice that this fraction here, we actually made it become this. These two are the same, and the shortcut is this. When you borrow, you automatically take 1 away from that number. So when we take 1 away from 9, we get 8. And if you add these two numbers together, 9 plus 15 is 24, and you still leave it over 15. That way you still have your common denominators. That's the shortcut. You just take 1 away from the 9 to give it 8, and then you add the numerator and the denominator together to get that new numerator. But that's a shortcut for borrowing. Nonetheless, this is our solution to that one. For problem C, we got 2 2/5, and we want to multiply this by 2 1/2. I'm not setting this problem up the same way I did with the addition and subtraction. I have mentioned, doing the vertical technique when dealing with mixed numbers. In this case here, for multiplying, the technique to multiply mixed numbers is to convert them back to improper fractions first. So let's convert these to improper fractions. 5 times 2 is 10. 10 plus 2 is 12. Therefore, 2 2/5 is 12/5. And then 2 1/2, let's do the same thing with that. 2 times 2 is 4, plus 1 gives us 5, so we have 5/2. And the nice thing about multiplying fractions, we do not need common denominators. To multiply fractions, we can take top times top or bottom times bottom. So we get 60 over 10, and that gives us 6. Oh, that's a nice answer. It's a whole number. We don't have to convert that back to a mixed number because we don't even have a fraction to worry about. Something worth mentioning though here, you could have taken, I guess, a shortcut. 60 divided by 10 is 6, but what you could have done was this. I've mentioned this. The 5s will cancel out, and you can do that when you are multiplying fractions. And we can actually take this 12 and this 2 and divide each one of these by 2. 2 divided by 2 gives you 1. 12 divided by 2 gives you 6. And notice we have 6 over 1, which is the same thing as what we have right here. Either way you get to that answer, I'm fine as long as you show me some work. And our last problem for number 1, question D, 4 1/5 divided by 4 2/3. Let's do the same technique we did with multiplication. Let's convert our mixed numbers to improper fractions. So 5 times 4 is 20, plus 1 is 21 over 5, divided by 3 times 4 is 12. 12 plus 2 is 14, so we have 14/3. The only thing about division, when you divide fractions, you need to remember to multiply by the reciprocal, or I do mention the idea of keep, change, flip. So we keep that first fraction of 21/5. Change our operation, that's what the C stands for. We change that division to multiplication, and then we flip this second fraction to 3 over 14. And now it's up to you how you want to multiply this. I'm going to go over both ways since this is a big review for your module exam. If we didn't cancel anything out to start off with, we could take 21 times 3, that's 63, and then 14 times 5, that's going to be 70. And now, is there something that 63 and 70 have in common? As a matter of fact, we do. We can divide these by 7. 63 divided by 7, well, 9 times 7 is 63, so 63 divided by 7 is 9. 70 divided by 7 is 10. 9/10 is your final answer. Be careful with these problems. If this thing right here was improper, we would need to convert it back to a mixed number since that's how we started our problem off. But we're okay with this since it's already a normal fraction or a proper fraction. Now, just to throw a little side note out there, if we had this same idea of 21 over 5 times 3 over 14, we do have a common factor that we can cancel out. We can divide the 21 and the 14 by 7. 21 divided by 7 gives you 3. 14 divided by 7 gives you 2. And now notice when you multiply these new numbers, 3 times 3 gives you 9. 5 times 2 gives you 10. Check that out. Got the same answer as what we did there. So either way you want to tackle that, I'm cool with it as long as you show your work. Alright, and I did want to go over these problems on the calculator. I am asking you to show your work, however, definitely use the calculator as a checking tool. If you are proficient in computing these problems by showing work, you should have enough time to go back and quickly check your work on the calculator. So let's do that. Let's do 8 1/3 plus 3 2/5. Remember the ABC button? That's what we're going to use for these mixed numbers. I've gone over that several times. So 8 ABC1, ABC3 plus 3 ABC2, ABC5. That's 8 1/3 plus 3 2/5. And we get 11 and 11/15. Notice that matches that right there exactly. So question B, 9 3/5, 9 ABC3, ABC5 minus 4 ABC13, ABC15. Let's see what we get there. 4 and 11/15. Look at that, matches up perfect. All right. Question C, 2 2/5 times 2 1/2. So 2 2/5 times 2 1/2. We get 6, and I think that's what we got over here. Yep, 6 right there. And then our last problem, what do we get there? We got 9 over 10. Let's see if we get 9 over 10 when we type this in. 4 1/5. So 4 1/5, using the ABC button still, divided by 4 2/3, 9/10. Perfect. All right, on to question number 2. So we want to show how to get 1/12 of a cup of flour if you only have measuring cups that measure 1 cup, 0.5 cup, or that means 5/10 of a cup. I like to think of a half. 0.5 is the same thing as a half a cup, 1/3 of a cup, and then we have 25 1/100ths of a cup. Well, 0.25, that's the same thing as a fourth. Now, since we're trying to get to a 12th, I'm going to go ahead and throw the answer out there, but the idea is you want to try to get some common denominators, and you might want to add, subtract, multiply, or divide to try to get 1/12. Let's look at the 1/4 cup that we have over here. However, let's write this as a common denominator of 12. Let's get 12 as our denominator. So if we have 12 as our denominator here, 1/4 is the same thing as what? 4 times 3 gives you 12, 1 times 3 gives you 3. So 1/4 of a cup is 3/12 of a cup. We want to use that. And now let's look at this 1/3 of a cup. So 1/3 of a cup, what does that equal to if we want to have 12 as a denominator? 3 times 4 equals 12, 1 times 4 equals 4. Check out these two fractions that we have here. We have 4/12 and 3/12. Notice if we subtract these, 4/12 minus the 3/12, this will be equal to 1/12. So there's our fraction. That's what we're looking for. We're looking for the 1/12 cup of flour. But how in the world do we do this with these two measuring cups? Well, first of all, we never used the 1 cup and we never used the half a cup. The only two that we used were the 1/3 and the 1/4. So to show this, I mean, you're showing me right there, but I want you to put a sentence or some type of explanation or a picture or something like that. What we did right here is we took the 1/3 cup and we subtracted the 1/4 of a cup. And that's how we got that 1/12. Now, what's really going on right there? The only two cups we're going to use here, again, we don't have that 1/12, but the way we got it is we take the 1/3 cup and suppose we fill that up with flour. But that's too much. Notice that 1/3 is 4/12. That's too much flour. All we want is 1/12. So if we fill that up with flour, we definitely have too much. But right there beside that, we have an empty measuring cup that is going to be the 1/4 of a cup. So what we're going to do, this 1/3 cup is full. Well, we want to take away a 1/4 of a cup. Well, how do we take away a 1/4 of a cup? Let's take this flour that's full in this 1/3 of a cup and let's dump the flour out of here, and let's dump enough flour to fill this up. So essentially what you're doing is you're taking a 1/3, you're taking that 1/3 right there, that 4/12, and when you add flour into here, you're taking it away from here. That's where the subtraction comes in. Even though we're filling this thing up over here, we're taking it away. So as this stuff's flowing into here, this flour is dropping, dropping, and once this one fills up, what you're left with the 1/12. So a way to explain this is like this. Fill up the 1/3 cup with flour. Pour out enough flour from the 1/3 cup to fill up the 1/4 cup. Let me get some room here. By doing that, you will be left with 1/12 of a cup of flour in the 1/3 cup. I know it can sound kind of crazy, but that's what you're doing. You're filling this up with flour. That's the 1/3. And you're going to pour out enough flour from here to fill this thing up. So really what you're doing is you're taking it away. You're subtracting off enough flour to fill that up. And what you're going to be left with inside of that 1/3 cup is 1/12 because you removed some of it. I know that can be confusing, but hey, I want to see your thought process on it. I've tried to give you a picture over here to explain that. I've showed the subtraction on how to get 1/12. And here's an explanation. I definitely want to see that and maybe a picture or some type of explanation for you to get full credit on that. Tricky, yes, but hey, I want to see the thought process. All right, question number 3. What fractional part of a whole circle, that should be circle right there, does the shaded piece represent? Well, let's look at this. 1, 2, 3, 4, 5, 6, 7 pieces. Let's double check that. 1, 2, 3, 4, 5, 6, 7 pieces, but how many are shaded? 1, 2, 3, 4. So 4/7 of a whole circle are shaded. If this was a pizza and all 7 of these slices were equal, if you grab those 4, you would have 4/7 of that whole pizza. And that's all we have right there. All right, this next problem, show how to reduce 140 over 490. Several ways. I'm going to do a couple here with you just to show you do have some freedom. What I don't want to see is just this equal to a fraction and you type it in the calculator and go on with it. I don't want to see that. I want to see some division. Okay? Some of you might notice that you can cancel these zeros out. That's something I've mentioned in class. So we're left there with 14 over 49. With that in mind, we can divide by 7 since 7 goes into both of these numbers. And therefore, 14 divided by 7 is 2. 49 divided by 7 is 7. That's our simplified fraction. Now, if you didn't cancel out the zeros, maybe you saw, hey, both of these things end in 0, so we can divide by 10. Let's do that. If you divide by 10, 140 divided by 10 is 14. 490 divided by 10 is 49. Well, that's the same thing we got right there. And the way we simplify that is to divide by 7, so we still get 2/7. I'm cool with either one of these techniques. I mean, there's many more you can do too. I'm going to show you one more. This is a longer technique, but hey, sometimes you got to take the long way to get to the answer. Both of these numbers are even. That works too. We can divide by 2. 140 divided by 2 is 70. 490. What's 490 divided by 2? 490 divided by 2, 245. But now we got to go one step farther or further. Since this ends in 0, this ends in 5, we can divide by 5. All right. 70 divided by 5. 70 divided by 5 is going to be 14. 245 divided by 5, that's going to be 49. And look where we're getting to. There's that 14 over 49 again. So that's going to be 2/7 because we've already divided by 7 here. Several ways to get to the same answer. I want to see some thought process. I don't want to see this. If I just see 140, if I see this on the test, throwing some stuff out there. If you do this, this is what I'm going to assume. If I see 140 over 490 and I see you write 2/7 and I don't see any of this, you're going to get partial credit. You're not going to get full credit for the problem. I want to see the work. Show how to reduce that. But while we have it as a checking tool, I definitely recommend this if you have the time. 140 over 490, let's just make sure that is 2/7. So using the ABC button, 140 ABC 490, 2/7. Good enough. All right, on to the next problem, number 5. Jane and 4 friends stopped at a bakery on Thursday and shared an apple pie equally. Be careful how you read this. Jane and 4 friends. So if Jane was with 4 friends, there's 5 people. If they shared an apple pie equally, that means Jane got 1/5 of a pie. All right, on Saturday, Jane and 9 friends. Jane and 9 friends makes 10 people in all. They stopped at the same bakery for a snack. This time the group shared 2 pies. Notice here for Saturday I got 2 pies. Each pie is the same size as the pie they had on Thursday. But notice how I broke this up. I broke it up the same way, to be quite honest. If there's 10 people, you can put 5 slices on one pie, 5 slices on the other pie, since they shared 2 pies. Now, how many folks are there? There's 10 people. So if Jane shared it equally with everybody else, look how much she got. How much did she get right there? She did not get 1/10. She got 1/5 of a pie. 1/5 of a single pie. Well, the question says, did Jane eat more pie on Thursday or Saturday? Looking at it like this, she ate the same amount. Jane ate the same amount of pie on Thursday and Saturday. So be careful with that. The thing here is I don't want you to get caught off guard where you might say she ate 1/10. But remember, there were 10 people. They had 2 pies. So 10 people, 2 pies, you got 5 slices per pie. If they shared equally, they're getting 1/5 of a single pie. Just like back here on Thursday, there was 1 pie. She got 1/5 of it then. Here she gets 1/5 of a pie. Therefore, Jane ate the same amount of pie on Thursday and Saturday. Kind of tricky there because you might be assuming by the question, did Jane eat more pie on Thursday or Saturday? Hey, she ate the same amount of pie. Be careful with your fractions there. On to number 6, and we actually got number 7 up here too. All right, number 6. Write the equivalent fraction for 11/5 with a denominator of 30. Our denominator goes at the bottom. We want to find an equivalent fraction. 11/5 is equal to what over 30? Back at the beginning of the video, or a couple of minutes ago, 30 minutes ago, I don't know, I've taken some breaks. But anyway, this right here, we're trying to figure out how do we get 5 to 30? We multiply by 6. So 11 times 6 is going to be 66. Therefore, 11/5 is equal to 66 over 30. And grab your calculator real quick. Let's check this while we have the time. Let's see. Okay, now if we did 11 ABC5, it's going to convert that to a mixed number. That's just how this calculator likes to work if we use the ABC button, which is fine. Let's see if we still get 2 1/5 when we do 66 over 30. Yes, we do. Same exact thing. But you're following the directions up here. It just says write an equivalent fraction for 11/5 with a denominator of 30, and that's what we created right here. So since we multiply by 6 at the bottom, we multiply by 6 at the top. And again, I did that earlier in this problem. Let's see, where was it? Right here. When we tried to write some equivalent fractions with the flour, multiplying the top and bottom. So, on to number 7. For a research paper, that person spent 3/4 of an hour searching the internet on google.com and 1/3 of an hour on chacha.com. How many more hours did she spend on google.com than on chacha.com? Typically, when you're asked for how many more, you want to subtract. All right, so, well, let's see. Let's look at the two fractions. We got 3/4 and we got a third. Now, maybe you can see this, maybe you can't, but 3/4 is bigger than a third. And if you can't see that, let's go ahead and find a common denominator right quick. 3/4 and 1/3, we can make them become 12. 12 is a common denominator. How did we get from 4 to 12? 4 times 3 gives you 12, so 3 times 3 gives you 9. How do we get to 12 over here? 3 times 4 gives you 12, so 1 times 4 gives you 4. Look at your fractions. 9/12 is bigger than 4/12. So we can just go ahead and subtract these things. 9/12 minus 4/12 is 5/12. But now, since this is a real world problem, let's make sure we type a sentence. So how many more hours did she spend on google.com than Cha-Cha? Well, Google was when she spent 3/4 of an hour. That's 45 minutes, by the way, just in case, but you don't have to know that. 1/3 of an hour. That's 20 minutes, by the way, but you don't need to know that either. But let's look at this. She spent, or what's her name? Caitlin. I'm guessing there's supposed to be a Y right there, maybe. I probably didn't copy it over right, but I'm going to call her Caitlin. Caitlin spent 5/12 of an hour longer on Google than she did on Cha-Cha. Okay, so there's the answer. That's good. If you want to pick up a little bit more information, listen to this. What did I just say about 3/4 of an hour? 3/4 of an hour is 45 minutes. If you look at a clock on a wall, 3/4 of the way around is 45 minutes. I know you're used to watching a clock. You watch the clock in class sometimes, I know. So, hey, think about that. What about 1/3 of an hour? 1/3 of an hour is 20 minutes. 20 minutes. What's the difference between 45 minutes and 20 minutes? 45 minutes minus 20 minutes is 25 minutes. 25 minutes. How does that relate to an hour? Again, I'm going off on a tangent here. I'm just trying to get you to pick up different ways of telling time and talking about time. 25 out of 60 minutes. What can we do with these two numbers? Let's divide them by 5. 25 divided by 5 is 5. 60 divided by 5 is 12. Hello, same answer right there. So to be quite honest with you, if you were to say she spent 25 minutes more or 25 minutes longer, either way, I would accept 5/12 of an hour longer on Google. Hey, if you would even say 25 minutes longer on Google, either way I'd accept it because, I mean, hey, I'm talking about it right now. Honestly, in my opinion, 25 minutes sounds better than 5/12 of an hour, but hey, I'd accept either one. Maybe you listened to this part, maybe you didn't. Maybe you're happy with the 5/12. It's up to you. All right. Number 8. Divide the circle into 8 pieces. Shade 1/4 of it. How many pieces are half of the 1/4 you just shaded? All right, let's see here. Let's take our circle. Let's divide it into 8 pieces. Alright, there's 4 pieces. Let's make the assumption that I'm going to be exact with this. Let's make the assumption that all these are equally sliced. That might be a little off, but hey, it's good enough. Alright, let's divide the circle into 8 pieces. We did that. Shade 1/4 of it. 1/4 of the circle. I'm just going to shade that right there. Now, why is that 1/4? Well, if we were to break it into fourths, 1/4 is the same thing as having 2 out of 8. If you were to simplify 2/8, don't we have 2 out of the 8 pieces shaded? And now, how many pieces are half of the 1/4 you shaded? We shaded 1/4. How many pieces out of this are half of what we shaded here? Notice, this 1/4 that we shaded, half of that is going to be one piece. One piece. So therefore, in a sentence, one piece out of the 8 pieces is half of the 1/4 that I shaded, or it could be you shaded. Now it's kind of weird. Let's look over that again. We divide the circle into 8 pieces. We shaded 2/8 or 1/4 of it in yellow. But how many pieces are half of that yellow region? Let's look at that again. How many pieces are half of that yellow region? That yellow region has 2 pieces. If we take half of it, we got 1 piece out of those 8 pieces total. That is half of the 4th that we shaded. So there's your sentence, there's your picture. I'll be looking for both of those. And now number 9, shade 0.6 of the figure, shade 6/10 of the figure. And let's assume that each section is the same size. What does 0.6 mean? 0.6 means a bunch of things. 0.6 is 60%. Moving the decimal 2 places to the right and tacking on the percent symbol. Or we could just say, hey, it's going to be 6 out of 10. Maybe you like that one better. 0.6 means 6/10. Think about the place value. So we have 6/10. Well, lucky for us, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can shade 6/10 pretty easy. There's 1/10, 2/10, 3, 4, 5. I'm shading a little quick. And there is the 6/10. Now, obviously, if be a little bit neater, maybe I should be too, but we don't want that shaded and that. But 1, 2, 3, 4, 5, 6 out of 10, 6/10. All right, that's 6/10 of the figure. 0.6, 60%. They all mean the same thing. All right, number 10. If 3 apples cost $4, how much would 1 apple cost? All right, now 2 ways to get confused here. Do you do 3 divided by 4, or do you do 4 divided by 3? Well, let's find out. 3 divided by 4, first of all, 3 divided by 4 should be pretty common fraction to convert into a decimal. That's 0.75. All right, let's look at that. Let's think about that. Let's go ahead and do 4 divided by 3. Now, 4 divided by 3 is going to be a repeated decimal, but if we go ahead and round it, you're going to get 1.33. You can do long division to do this, or at this point, you're taking the exam and you're probably kind of burned out on showing a lot of work. Since it does not say show how you did it, you can show me 4 divided by 3, but you don't have to show the long division. So check it out. 4 divided by 3 is a repeated decimal. Which one of these makes sense to you? Think about this. How many apples did we buy? 3 apples. How much did those 3 apples cost? $4. So how much would 1 apple cost? This one right here does not make sense. Think about that. If you're saying that 1 apple costs 75 cents, 75 cents times 3, I don't care what it is, it's not equal to $4. 75 cents times 3, what is that? 75 times 3, $2.25. It's not equal to $4. This one right here right here is the one that makes sense. So let's look at that. Now unplug the calculator. Fantastic. Alright, so that 4 divided by 3, 1.3333, blah, blah, blah. So that's the price of one apple. How many apples did we buy? We bought 3 of them. So let's multiply that by 3, since that's the cost of one times 3 apples. Bam, back to 4, just like that. So I don't mind seeing you just, doing a little trial and error. That's what I was showing you here. Do you do 3 divided by 4 or do you do 4 divided by 3? It is not 75 cents an apple. Think about the problem. If you paid 75 cents an apple for 3 apples, well, right there it says you paid $4. 75 cents times 3 was $2.25. So that does not make sense. This is the one that you want to use. And essentially what you're doing is you're taking the cost divided by the quantity. Now, something that has not been mentioned a lot in here is something called unit cost. How much are you paying for 1 unit, or if you go to the grocery store, how much you're going to pay for 1 pound. But cost divided by quantity. $4 divided by 3 apples. So a complete sentence there. 1 apple would cost $1.33. All right. Number 11. I think we can squeeze that in right here. If you make $10.92 an hour, estimate your weekly pay before taxes if you work 35 hours per week. All right, so we make $10.92 for every hour that we work. That's pretty good. It's better than minimum wage. And if you work for 35 hours, you want to multiply by 35. Now, here it doesn't say show your work. As long as I see you set this up, I mean, sure, go ahead, spend a minute or two crunching this out. We'll do it anyway since we're on the video, but it doesn't say show your work for this. As long as you recognize, hey, you need to multiply this. $10.92 per hour for 35 hours means you multiply. So let's go ahead and hash this out. 2 times 5 is 10, 0 carry our 1, 9 times 5 is 45, plus 1 is 46. 5 times 0 is 0, plus 4 is 4, 5 times 1 is 5. Let's bring a 0 down, and now let's multiply the 3. 3 times 2 is 6, 9 times 3 is 27, 3 times 0 is 0, plus 2 is 2, and then 3 times 1 is 3. Let's add all this stuff up. 0, 12, 12 again, 8, and 3. So now we made $38,220. Yeah, right. Be careful here. You do want to move that decimal. Since we have 2 digits to the right of the decimal, we want to come and put that decimal 2 places to the left. Therefore, we have 2 digits to the right of the decimal here as well. We didn't have any digits to the right of the decimal right here, so the only thing we had to worry about was this one. So how much are we going to make? We are going to make, this is before taxes. It's not we, it's you. So let's say, I will make $382.20. And now, like I said, you don't have to show all that. That's why I kind of zoomed through it. If you want to show it, that's fine with me. But let's check our work there. Back up to the problem. $10.92 per hour. So, get some light on this. And how many hours do we work? What did we say? 35 hours. So 382.20. Now it's missing the 0 there, but I've mentioned that in class too. 0.20. You can put a 0 on the end of it, and it wouldn't change the actual value of that number. So again, we would make $382.20 that week. On to number 12. All right, what would you use? Would you use circumference or area for each of the following? So 12A, what are we going to use? Are we going to use the circumference or the area? To buy a ribbon to go around the bottom of a dress. You got a dress. Now technically this dress, not the best artist, but there's our dress. That dress actually is a circle. Let's not get too technical here. If we're trying to put a ribbon around the bottom of a dress, that is going to be circumference. Remember, the circumference is the distance around a circle. If we assume this dress to be a circle and we want to put a ribbon around it, we have to use a circumference. Whereas for question B in number 12, to determine the better buy between a rectangular pizza and a round pizza. To determine that, you don't want to use the circumference or the distance around. What you want to use is you want to figure out how much area. Because when you eat pizza, you're eating, you take a rectangular pizza. You cut it into slices. There's a slice, 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 there's a slice. Down here in this circle, you might have slices like this. But what are you doing here? I know I'm sloppy with my lines, but you're filling up the area. You're talking about the area of the rectangle, the area of that circular pizza. So there, to determine the better buy, we would use the area. I don't care about the distance around that thing. I want to know how much pizza is filling up that space, and that's what area talks about. Again, I don't care about the distance around this circular pizza. I care about how much area those slices are covering up. So therefore, area is the better measure there. And all right, 13A. First of all, there is a round picnic table with a diameter of 6 feet. We'll just do a quick circle. Be careful with your measurements here. This circle has a diameter of 6 feet. Remember, the diameter is the distance across the circle, and make sure you're going through the center. That's pretty close right about there. I'm not even reading the rest of the problem, and I'm going to go ahead and start writing some numbers down. 6 feet is the distance across this circle. With that in mind, I'm going to go ahead and talk about the radius before I even read any more of the problem. If that's the center of the circle, that means the radius is going to be 3 feet. And now let's read the question. Question A, how many square feet of material do you need to make a tablecloth? Think about a tablecloth. A tablecloth will cover the surface. It'll cover the entire surface of the picnic table. So how many square feet? That's another key word too. Square feet. Anytime you talk about square feet, square yards, square inches, you want to find the area. So for question A, we want to find the area of that circle. Area equals pi r squared. Well, that's why I went ahead and drew and wrote some random numbers up here. But remember, the diameter was 6 feet. That would have been the distance across the circle. That 6 was that. 3 feet was the radius. Remember what I drew a couple of minutes ago. So therefore, the area of this circle, pi, the radius is 3. So it's pi times 3 squared. That's what pi r squared means. Pi times the radius squared. Now, please do not spend too much time trying to crunch this out pencil and paper. I would definitely grab the calculator on this to find the area of that circle. So let's do that. Remember, pi is located right here on your calculator. That's the pi symbol. So we will do pi times 3 squared. And actually, you can type it in just like that. Pi 3 squared is the same thing, 28.3-ish. Watch this. Pi times 3 squared. Same thing. You don't have to put the time symbol there if you don't want to. So let me come back and write. Instead of A equals, how about A is approximately? Let me change my eraser. So the area is approximately 28.3 square feet. I don't mind whether you write it as the feet with the squared, or you can write it as square feet. Either way, whichever one works for you. But so to answer the question, how many square feet of material do you need to make a tablecloth? You need 28.3 square feet of tablecloth. Now for question B, let's omit that because I don't think there's enough information, and quite frankly 10-foot wide bolts, I don't know. Let's just skip that problem. You won't have one like that on your final or on your DMA module exam. However, question C, definitely want to know this one too. Question A, we used the area because we wanted to cover the surface. We wanted to find the square feet needed to cover this picnic table. Question C to number 13, if you want to put elastic around the border to hold it into place, how many feet of elastic do you need to purchase? So what we're talking about there is we're putting a tablecloth up here and we want to put some elastic around this to keep the tablecloth from blowing off. How many feet of that would we need to purchase? So what we're talking about now is we're talking about putting something around the edge of this circle. Well, that's talking about the distance around the circle. So for question C, we keep everything organized, somewhat organized. We want to find the circumference, the distance around that circle. You have two formulas for circumference. You have circumference equals 2 pi r, or you could use circumference is equal to pi d. It's up to you. Just make sure you use the right number. Since the diameter was given to us, and since that was the last one I wrote here, I'm going to use this formula, just making sure the diameter, we said the diameter was 6 feet. So therefore, circumference is equal to pi times 6. Now keep in mind, 2 times r, just to throw this out there, 2 times r, what was the radius? The radius was 3, so 2 times 3 still gives you that 6, whether you wanted to use 2 pi r or pi d. But anyway, here we definitely want to go back to the calculator to crunch this out as well. So therefore, pi d or 2 pi r, I'll show it to you right here on the calculator just in case you weren't following with that. Pi d would be pi times 6. So we got 18.8. Or we could do 2 pi r. 2 pi r would be 2 times pi times the radius. The radius was 3. Oh, there's that same number, 18.8. So 2 pi r, 2 times pi times the radius, or we could do pi d, which would be pi times the diameter. No matter how you crunch it out, you're going to get 18.8 if you round. So the circumference is approximately 18.8 feet. Now we don't put that in square feet because we're not talking about area. So therefore the answer to question B would be you would need 18.8 feet of elastic to, let's just say we would need 18.8 feet of elastic. That would be fine. Because again, that elastic is going to go around this circle. So here's the answer to question A, whereas this is the answer to question C, because remember we skipped question B. Don't worry about question B right there. And now, finally, the last problem. Let's express each of the following in scientific notation. About 22,750,000 young people ages 18 to 29 voted in the 2008 presidential elections. What is that in scientific notation? Well, first of all, that's a big number. 227500000. Be careful with your zeros there. We want to express this number in scientific notation. We don't see a decimal, so therefore I'm going to assume the decimal's there, and it is there. And we're going to move this decimal to the left. So 1, 2, 3, 4, 5, 6, 7. Now why did I stop right there? Let me go ahead and write this out. 2.275. I'm not worried about those zeros since there's no other non-zero digit occurring after these zeros. But the reason why I stopped right there is because for scientific notation, you only want one digit to the left of the decimal when you convert to scientific notation. So 2.275, that number is a lot smaller than 22,750,000. So what we want to do is we want to make this number get big. And the idea is if you move to the left, how many places did we move to the left? 1, 2, 3, 4, 5, 6, 7. We moved 7 places to the left. And the thing with scientific notation, there's always going to be a 10 to some power. We move to the left, we use a positive number. And the reason why we use a positive number is because this number right here, 2.275, is very small compared to that. So to make this number bigger, we want to raise it to 10 to a positive power. But just think left, you use positive numbers. And that's it. That's this number in scientific notation. Just count how many places you move to the left. We move 7 places to the left, so we're going to use a positive 7. And let me go ahead and show that to you on the calculator. And that number right there in scientific notation, this right here, is going to be 22,750,000. I'll do it right here. So let's type that in. 2.275 times 10, and then remember your exponent key is right there. That one right there. So let's raise that to the 7th power. 2.275 times 10 to the 7th. Look at that. 2275, and we got 4 zeros. Well, check out your number. 2275, and you got 4 zeros. But that's scientific notation. Again, you only want one digit to the left of the decimal, and then since we move to the left, we want to use a positive exponent. However, for question B, it's going to be kind of the opposite. That's a really small number. The mass of a dust particle. Dust particle, I mean, you dust your house. A little tiny piece of dust, very light. The mass of it, pretty much nothing, but hey, we have a number here. Alright. I don't even want to count those zeros, so I'm just going to make this easier to work with. Let's make it big so we can move our decimal real easy. How many places are we moving this? Let's see. We only want the 7 on the left side of the decimal. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. Alright, so what number did we create when we moved this thing 10 places to the right? We got 7.53. That 3's kind of cut off, but hey, it comes from right there. Now, 7.53 compared to this number, 7.53 is big compared to that tiny, 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 tiny number. So we want to multiply by 10 raised to some power. When we move to the right for scientific notation, we want to use a negative number. Well, we use a negative 10 since we move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the right. And again, I move that many places because we want one non-zero digit to the left of the decimal when we write this in scientific notation. So that is our scientific notation for that. That number is really small. This number right here is bigger than that, but when we use a negative exponent, it's essentially going to make it smaller. Now, and there you have it. 14 problems. I imagine this video's approaching an hour somewhere, but if you've watched this, if you understand this, you'll do fine on the module exam. And if you don't understand something, don't wait until the last minute. Ask me some questions on the review days, and you should be just fine. And that is it for this video. Hope it helped.